Yeah, over the course of the pandemic, when I had a little bit of extra free time on my hands, I decided to start upstreaming some of the PDU processing blocks that I spoke about in 2019. And the idea here is that some of these would benefit a lot from being more integrated into GNU Radio. And I decided that since I've been doing that, I would take a few minutes and walk through a little bit of the motivation there, the process there, the status, and where it's going. Not work. So this has been talked about a bit. What PDUs are? They're pairs of metadata and data. So you can stick whatever sort of key value metadata you need to keep track of what the data means and pass it around in GNU Radio or over networks and things like that. Typically within GNU Radio, these are moved around using the asynchronous message passing API. So this is a little bit different than most of the examples that exist out in the world for GNU Radio. I'm not going to. There is the talk from 2019 covers all of this a little bit more in detail, and I don't want to repeat all of that now. But what I do want to talk about is, why we're upstreaming these now and where it's going. So all of this work started primarily because I had a very simple thing that I wanted to do. I wanted to receive data from a bursty modem, and then I wanted to transmit slightly different data back at a specific time and frequency of my choosing. And it's not very straightforward to implement that with what has been in GNU Radio for a long time. You can, and there's lots of workarounds to use the streaming API to do things like that are really conceptually more discrete operations. A message of data I want to emit at X frequency at X time to interact with a real radio out in the world somewhere is easier to handle when you have all of that information contained in a single data object. There are tag stream blocks which have existed for a long time, and conceptually they do the same thing. There's just a lot of bugs and annoyances in working with them, and they're scheduled for deprecation at some point in the future. I don't know if we're ever going to do that, but we should. So the general idea here is just to make some of these. So yeah, the general idea here is to make these conceptually straightforward things equally straightforward to implement in software radio. There are a couple just general disadvantages when working with PDUs. One is that as soon as you get away from the streaming interface, which has this nice concept of back pressure enabling all of these really high performance things that we do with GNU Radio, losing that reduces performance and throughput a little bit. There's also an infinite queue depth with PDUs, so if you shove a ton of PDUs and PDU data in to a block faster than it can process it, you're going to end up with giant backlogs. So it requires a little bit of user-side management to make sure that doesn't happen. You also have to deal with PMTs, and with the work that John Sally's doing to update those, it will directly benefit all of these PDU applications when we move towards a slightly more sane library for dealing with PDU or PMT type objects. So a couple other things that have gotten upstreamed along with this are some sane type checking. So historically there's been some problems with dictionary type objects. These are all PMT quirks where everything is composed of pairs, which are all under the hood more and more and more pairs. There are some additional PMT checks that are going to make it easier to work with PDUs. Standardizing vector data types. Technically, you can use any data type you want with PDU, but if you stick with some of the more sort of 5 common ones you'll use in GNU Radio a lot, it makes your life a whole lot easier. There are also a bunch of common message port names and metadata keys that are being upstreamed that are in GNU Radio runtime now, that you can use the getters for those to save a bunch of extra work in out-of-tree modules that are using PDUs. Building flow graphs, the sort of general process for working with PDUs or building applications that rely on this method of processing is to find a way to convert your streaming data, which most sources are going to operate on, are going to provide streaming data of some sort, to tag features in that data and use one of the now in-tree blocks like the tags to PDU block to aggregate the streaming data, put it into a PDU and pass that out for downstream processing. There are a couple general ways to do that. You can do demodulation conventionally with the symbol sync block, like a lot of the example flow graphs do, or some sort of other appropriate synchronization for what you're doing. You can do that all in the streaming domain and convert, demod everything and convert the demodulated data into a PDU, or you can do something like you can do energy detection and tag your streaming data based on energy and only save off the bits and pieces that the streaming data that you care about and process that downstream for clock recovery, synchronization, demodulation, and so forth. As I mentioned, the original motivation for this was really for transceiver-based applications where you actually want to transmit in addition to like something in the real world, another radio. The general philosophy of doing that with gr-pdu is sort of outlined here, where you convert your data into to a PDU and pass that into some sort of higher level application. So GNU Radio has always been really, really excellent for doing like physical layer processing, but there are some limitations when it comes to building higher layers directly in streaming blocks, and this makes it a lot easier. If you're operating on the entire data packets at a time, it lets you, be more deliberate about what you're doing with that data, how you're creating responses to that data, how you're implementing your modem, how you're doing link management, and it's just a lot more convenient. The module today, so we've moved a number of blocks out of GR blocks, the great catch-all, and into gr-pdu, which are shown here. There's some reorganization, and quite a few blocks have been added. There's a great block, the PDU lambda block, is now in tree, which allows you to design you feed it an arbitrary function and it'll just do that function on all of your data. It's great. There are some examples in tree now that cover all of the blocks that have been added, and I have an example set up that I built last week for it's running out over in the vendor demo area. So at my house, I have young children, so I have a bunch of baby monitors, and there are a couple out of tree modules that have existed in the 3.7, 3.8 days, and they work really good. I tested them out, and sure enough, I'm sitting in my home office and I can hear my son's baby monitor through GNU Radio. So, naturally everybody can. And so the next step is forget that. It's a little bit bizarre that it is so easy to do that. And, these things work at quite long range. So I put an example on GitHub this morning that uses some of these blocks and some of these concepts. If you guys who are here in person want to try that out, there's a pair of baby monitor units sitting up in the vendor area. So take a look, try it out. So future of this, there are a number of additional blocks that I intend to add and upstream over the next few months, hopefully before 3.10 is actually released. I will continue building reference flow graphs for all of those. The original out of tree modules will continue to live on and be maintained. Not everything will be upstreamed. Although I am interested to know if there are particular things that people would like to see. Hit me up on Matrix chat and let me know. Moving forward, sort of mentioned this already, but moving towards the new PMT library, that'll be a performance increase, hopefully, very soon. And the other thing that I'll be looking at is sort of extracting some of the common DSP between the existing streaming blocks and new PDU blocks that are doing functionally the same thing. Like, for example, there's a PDU quadrature demodulator block. It would be great if it used the exact same underlying DSP instead of a copy of the streaming one, things like that. Yeah, there are a couple things that I have not put really any effort into. So some of these would be blocks to do like PSK or multi-carrier synchronization. That'd be interesting. It would be a good thing to add. If anyone in the community is interested in doing that, that would be awesome. Yeah, and that's all I've got.
Cool. All right. Thanks, Jacob. Any questions for Jacob here? All right. I have a question, and that is, as far as when you talk about having the same block handle both PDUs and streams with the same signal processing, do you have a particular structure in mind to do that, or?
No, you pretty much saw what I have in mind. Very much conceptual. I don't. I'm open to suggestions. I just there are a lot of entry blocks and functionality that are like very, very essential to almost any flow graph, like FIR filters or demodulate, like simple quadrature demod, things like that. And right now, I've just basically ripped out the exact same DSP, same vault calls, all that stuff out of the streaming stuff. Streaming blocks, put them into the PDU blocks, but it would be nice if there was a way to keep that common.
Yep. Cool. Any other questions for Jacob? All right, exciting stuff. All right,
Thanks.
Glad you've taken on this effort.